Alright, today's video is on 2.8, graphing absolute value functions, and this is the last section of new material before we take our test. So first, let's start with our general form of an absolute value equation. We've got y is equal to a, the absolute value of x minus h, plus k. This form should start being a little bit more familiar to you. Every equation we deal with this year is going to be some form of this equation with the h and the k. Now let's start off with the A. The A is what's going to determine your shape. And it's going to determine your shape because it represents the slope or the rate of change. Then there is the H. The H, think about H, a horizontal shift. Now when you have the horizontal shift, it's the opposite of what you think. Anytime you have something inside of parentheses or a grouping symbol, in this case the absolute value sign is our grouping symbol, when you bring it out it's going to be the opposite. So since you have the minus h, in this case h is positive. And k is going to be your vertical shift. The vertex is going to be at h comma k. So as we said before, your shape is going to be determined by a. If a is equal to 1, you're going to have a normal shape. If a is greater than 1, you're going to have a narrow shape. And if your a is between 0 and 1, it's going to be wide. Now if a number is between 0 and 1, it's a fraction or a decimal, like 1/4 or 1/2. Be very careful. Just because it's a fraction doesn't mean it's going to be wide. If you have a fraction like 3/2, 3/2 is 1.5, which means it's greater than 1, which means it's going to be narrow. So make sure that your number is between 0 and 1, making it a wide shape. If a is positive, then it's going to open up. If a is negative, then it's going to open down. Alright, so let's start graphing our absolute value equations. We've got y is equal to the absolute value of x. Now let's start just by plugging points in. So if I plug in 0, the absolute value of 0 is 0. So I've got point 0. If I plug in the absolute value of 1, I get 1. Absolute value of 2 is 2. Absolute value of 3 is 3. 4 is 4. Now, what's going to make this different from then just a regular line with a slope of 1 is if I go in the opposite direction, if I go to -1, the absolute value of a -1 is a positive 1. The absolute value of a -2 is a positive 2. Absolute value of -3 is 3. Absolute value of -4 is 4. So the absolute value graph is going to be the graph of a V. It's going to be in the shape of a V. When I look at my general form of the equation, I see here that my a value is that number there, and since there's no number, we're going to assume that it's 1. Because our a is 1 and it's positive, that means that we're going to open up, which we see our graph does open up. Our shape is going to be a normal shape, and our vertex, which is that pinnacle point right there, is going to be at 0, 0. There's no number being added or subtracted inside the absolute value bar, and there's no number being added or subtracted on the outside. When we look at number 2, again, let's look at our a value. This time let's look at it first. Our a value this time is going to be a -1. That means that it's going to open down instead of up. It's still a 1, so our shape is still going to be normal. And our vertex is still going to be at 0, 0. Because there's no number being added inside, there's no number being added or subtracted on the outside. So our vertex is still 0, 0. If we were to plug in numbers, if I plug in 1, the absolute value of 1 is 1, but the negative's on the outside, so that makes my answer a -1. Absolute value of 2 is 2, but I added that negative, gives me a -2. and so forth. So then if I plug in a negative 1, the absolute value of a negative 1 is still a positive 1. Then we add in that negative. And we can see that we have that exact same graph that we had from number 1, except for having that negative on the outside is going to flip it from facing up to be facing down. Next, we look at our a value. In this case, our a value is a 1/2. It's positive, so it's going to open up. The shape, because it's a fraction between 0 and 1, it's going to be a wide shape. And our vertex, can we look in? There's no number being added or subtracted inside the absolute value bars. There's no number being added, subtracted on the outside. So our vertex is still at 0, 0. So we start at 0, 0. Now we know that our shape is going to be wide because of our a value. If you remember, we said our a value not only determines the shape, but it also is representing the slope or the rate of change. So we have a slope of 1/2. We know that it's going to open up. So I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. But we also know that we're going to have a V shape. So not only do we have to go up 1, right 2, we also have to go up 1, left 2, up 1, left 2 to get that shape of our V. And we can see, compared to when our slope was 1, we have a wider graph. It's going out because our slope is a smaller number. The larger the slope, the faster it grows, which means the more narrow it's going to become. Since we have a fraction between 0 and 1, it's growing at a slower rate, which is going to make our shape wide. Alright, number 4, we've got y is equal to the absolute value of x plus 2. We look at our a value. The a value up front, a is equal to 1. A is positive, so it's going to open up. It is 1, so the shape is going to be normal. Now we have a number being added. Remember, the horizontal shift happens on the inside, the vertical shift happens on the outside. So there is no horizontal shift to our vertex, so our x value is still 0. But now we've gone up 2, so we're going to start at 0, 2. So we're going to start our vertex at 0, 2. We are going up with a normal shape, which means we're going up with a slope of 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. And you can see that there is our V-shaped graph, our absolute value. It's exactly like we had in number 1, except for it has been moved up 2 spaces from the origin. Alright, turn that sheet over. Looking at number 5, we've got y is equal to the absolute value of x plus 3. We're still going to start by looking at that a value. Our a value is 1, so we are going to open up. It's 1, so it's going to have a normal shape. This time, our change is happening on the inside, which means we're going to have a horizontal shift. So when we look at our vertex, it's no longer going to be at 0. Because it's inside of the absolute value bars, remember, it's going to be the opposite of what you think. Since we see a positive 3, it's actually going to be a negative 3. We're actually doing a horizontal shift left 3. There's no number being added on the outside, so it's negative 3, 0. So we got a vertex, negative 3, 0. Slope of 1 opening up, so we go up 1, right 1, up 1, right 1. Continue that, and then we go the other direction to make the other half of our V. And you can see that we've taken that normal absolute value bar, or absolute value graph, and just moved it 3 spots to the left of the origin. Number 6, we've got our a value is 1. So what I want you to do now is press pause and see if you can give me all of the important information that I need. For every single absolute value problem, you should be listing out those 3 pieces of information. Once you're done, press play and see if you were right. Alright, so let's see if you got it right. It was positive, so it's going to open up. It was 1, so it's going to have a normal shape. opposite of what we see on the inside, and just remember the x-coordinate goes with the x variable, so a positive 2 for your x-coordinate, a negative 3 for the y-coordinate. So we're going to start at 2, negative 3, and our slope, or our a value, is 1, so and it's going to open up, so we go up 1, right 1, and we go up 1, left 1, creating that V shape in our graph. Alright, 3 more graphs to go. Number 7, we've got y is equal to a negative absolute value of x plus 4 minus 3. We've got our a value there is equal to a negative 1. That means that our graph is going to open down. It's a value of 1 still though, so we're still going to have a normal shape. And then our vertex is going to be at a negative 4, negative 3. So we go left 4, down 3. There's our starting point. Our a value is a negative 1, meaning it's going to open down. I still have a slope of 1 though, so I'm going to go right 1, down 1. So that I can create that graph opening in the downward direction, but still having a slope of 1. Number 8, we see that our a value is equal to 2. Since our a value is 2, it's positive, which means it's going to open up. It is greater than 1. It's going to have a higher slope. It's going to be more narrow. Since it's greater than 1, we've got a narrow shape. Opposite of what you see in the parentheses for your vertex, so a positive 2, exactly what you see on the outside, a positive 4. So our starting point is at 2, 4 for our vertex. We're going to open up, so we know we're going to build our graph upwards. It's narrow. That slope is 2, which means if I want to make it into a fraction, it would be 2 over 1, up 2, right 1, up 2, right 1. Make your V, so we also go up 2, left 1, up 2, left 1. And our last graph for today, we've got y is equal to a negative 1/4 x plus 3 minus 6. So our a value there is a negative 1/4. Since it is negative, our graph is going to open down. Since it's a fraction between 0 and 1, we're going to have a wide shape, opposite of what we see on the inside for the x, exactly what we see on the outside for the y. So our vertex there is going to be at a negative 3, negative 6. Now we know we're going to open down, so we know we're going to move in the downward direction. Our slope is 1/4, so we're going to go down 1, right 4, down 1, right 4, down 1, right 4. Now to get the other side of the V, we go down 1, left 4, down 1, left 4, we run out of room, right there. Connect those points. And again, you see that the bigger your slope, the more narrow your graph's going to be. The smaller your slope in that fraction, the more wide, the more spread out it's going to be. And that is it for today. You are done.